Hello, thanks for clicking. Welcome to another Calculus 2 production. Today we're going to be learning about how to differentiate parametric equations. So in the last video, we had a little bit of an introduction to parametric equations. We talked about what they were, how you would write them, how you could graph a set of parametric equations and make a plane curve. Okay. Today we're actually going to go ahead and do some calculus with them. All right. So let's get started. So let's talk about the slope of a tangent line of a smooth curve. So suppose a smooth curve C is represented by x is equal to f of t and y is equal to g of t. Then the slope of the tangent line to the curve at the point xy is given by, so I want the slope of the tangent line to the curve at the point xy. Well, I know how to find the slope of a tangent line. The slope of a tangent line is dy dx. We agree? Dy over dx. But I don't have dy dx here. I have x and y written separately in terms of t, right? So I have an equation like x equals t squared and y equals t cubed plus 2, let's say. So how do I find dy dx if I know what x and y are in terms of a third variable t? Well, it's actually pretty easy, because if I derive x, the derivative of x with respect to t would be dx dt, right? dx dt would be 2t. The derivative of y with respect to t, because that's the variable over there, is 3t squared. Now, to find dy dx, if I were to take dy dt and divide by dx dt, don't I get dy dx? Right? If I wanted to flip this over and multiply it up there, I'd be multiplying by dt over dx. And then the dt's would drop out, and I end up with dy dx. Okay? So that is how you find the slope of a tangent line in parametric form. So dy dx is equal to dy dt divided by dx dt. As long as dx dt is not 0, right? If dx dt is 0, okay, then the slope of the tangent line is undefined, right? And that would be a problem, okay? So it's a pretty simple definition. All right, let's put it into practice. So let's find dy dx if x is equal to t e to the t and y is equal to t plus sine t. So dy dx is equal to dy dt divided by dx dt. All right, let's find dy dt first, I guess. It's in the numerator. So y is equal to t plus sine t. So dy dt would be 1 plus cosine t. And then if x is t times e to the t, I have to use the product rule. So dx dt will be, leave the t, derivative of e to the t is itself, plus leave the e to the t, derivative of t is 1. So then dy dx is 1 plus cosine t divided by t times e to the t plus e to the t. And that's what the derivative is, dy dx. It's dy dx, but written in terms of t. And that's okay here because we're talking about parametric equations, written in terms of a third variable. You may want to factor out the e to the t as well. You're going to see we're going to do some calculations with this, not this function particularly, but with something a little later on. Keep in mind you could factor out e to the t. So dy dx would also be equal to that. Okay? All right. So let's consider these next two parametric equations. I want to write the equation of the tangent line at t equals 4. Okay. So now, equation of a tangent line. I need two things to do that. I need to know the slope of the tangent line, and I need to know a point on the tangent line. Well, the slope of the tangent line, I know that. That's dy dx. To find dy dx, I have to find dy dt and divide by dx dt. So let's find dy dt. dy dt is 2t minus 2. dx dt, x is equal to square root t, dx dt, that's really t to the half. So that's going to be 1/2 t to the negative half. So this is going to be 1/2 t to the 1/2. All right, so that's dy dt divided by dx dt. Now I could flip this over here, and I could rewrite it if I wanted to, if you needed to. It would be 2t to the half times 2t minus 2. You could also do a little work if you wanted to. Again, you don't have to do this. So that would be 4t to the 3/2 minus 4t to the 1/2, right? That's what dy dx is equal to. Okay, so that's 3 different ways to write the same thing. 1, 2, 3. Any 3 are valid. Now, but I want to write the equation, the tangent line at t equals 4. So I want to take dy dx and evaluate it at t equals 4. So we can do that. I'm going to do that with this first equation. I think it's a little easier to work with. So that's going to be 2 times 4 minus 2 over 1 plus 2 square root 4. So that's 8 minus 2, that's 6. 2 times square root 4 is 4. And then I'm going to flip over the 1/4. It gives me 24. So the slope of the tangent line is 24. But now to write the equation, I also need to know a point for the tangent line. A point is an x coordinate and a y coordinate. Well, how am I supposed to find an xy coordinate? This thing is written in terms of t, but I know t equals 4. So if I take t equals 4 and substitute it into each one of the equations, it will tell me what the xy point would be. So x is the square root of 4, so that's 2. And y is 4 squared minus 2 times 4. So that's 16 minus 8 is 8. So there's my point. So now I got a slope and I got a point, and I can write my equation in point slope form. So y minus 8 equals 24 times x minus 2. And that's the answer. Okay, so we're doing the same calculus that you've been doing, except we just added a third variable in, and it kind of changes things around a little bit. All right, finally, let's talk about these two parametric equations. And let's try to find the point or points on the curve where the tangent line is horizontal or vertical. All right, so if a tangent line is horizontal, that means the derivative dy dx would have to equal 0, right? Okay, 0 slope for horizontal line. If there's going to be a vertical tangent line, then dy dx would have to be undefined. Okay, dy dx would have to be undefined, right? The slope is undefined. Here, the slope is 0 for a horizontal line. All right, but again, we got to find dy dx to do that. So dy dx is equal to dy dt divided by dx dt. Okay, so dy dt is 3t squared minus 6t. 3t squared minus 6t over dx dt is 3t squared minus 3. All right, so now let's start with the horizontal line. That means the derivative would have to equal 0. For this to equal 0, then the numerator has to equal 0. So 3t squared minus 6t will have to equal 0. Let's factor out a 3t. And we'll split them both. We get t equals 0 and t equals 2. Okay, great. But I don't want to know what t is equal to. I want the point or points on the curve. Well, the points on the curve have coordinates x and y. So I have to take 0, t equals 0, substitute it back in to my x and y. So we'll put it here. If t equals 0, I get the xy point. Well, 0 goes in here. X comes out to be 0. And then y would also come out to be 0. If t equals 2, that would give me So 2 cubed is 8. 8 minus 6 is 2. And 2 cubed is 8 minus 12, negative 4. So those are my 2 points where it's horizontal. Now I need to figure out where it's vertical as well. So let's come over here and erase a little bit of this. That way we have a little bit of room. And we'll also erase this because we don't want it to be equal to 0 anymore. So it's going to be vertical when the slope of the tangent line is undefined. So where would the slope be undefined? Well, that would be when the denominator is equal to 0, right? The derivative dy dx would be undefined. So I need to know where 3t squared minus 3 is equal to 0. So I could solve this, I guess, pretty easy. 3t squared is equal to 3. Divide by 3. T squared is 1. Take the square root on both sides and put plus or minus. So t equals plus or minus 1. Okay. But again, I need points. So if t equals negative 1, I substitute that in back up top. Negative 1 cubed is negative 1. And 3 times negative 1 is plus 3. So that's 2. And then negative 1 cubed is negative 1. Negative 1 squared is 1. Times 3, negative 4. And then if t equals 1, I get 1 minus 3 is negative 2. And then I plug this in, and I get 1 minus 3 is negative 2. Right? Yeah. Okay. And that's it. And as always, thanks for clicking.